Hi there. I promised you I would work out these problems that we had from the Red Book, Chapter 5, numbers 5, 79, and 86. And I'm going to do number 5 right now. It reads that Sudhir walks 0.40 kilometers in a direction 60 degrees west of north, then goes 0.50 kilometers due west. What is his displacement? Okay, so 60 degrees west of north means, well, I'm going to start somewhere in this vicinity over here, draw kind of a compass rose, north, east, south, west. 60 degrees west of north is a bit, 60 degrees west of north is that way by 60 degrees. So it's actually more like this. More like 30 degrees over on this side and 60 degrees on that side. He walks 0.40 kilometers in that direction, then goes, and I'm going to say that's about 0.4, and then he goes due west for about 0.5, so this one better be a little bit longer than that. This is just a sketch. I just chose graph paper because I had it sitting here. What we are supposed to determine is we are supposed to figure out let me get another color. We are supposed to figure out his total displacement. In other words, a straight line that goes from the beginning over to there. And again, that was a sketch that was very messy. I did not get out a ruler. I did not get out a protractor. But that, okay, so our first vector we're going to call A. Our second vector we're going to call B. What the vectors add up to we're going to call R. And I think we will find this angle here for the angle associated with R. This angle right here was, better put it blue, the angle or theta associated with vector A. Now, in order to find R, we want to make a bit of a table. We want to say that we have three vectors. We have A, we've got B, and we've got R. And these things have an X component, they have a Y component, and they have an overall magnitude. We don't need the magnitude in here. We need the components. We're looking for this guy, we're looking for this guy. Between those two things, we can figure out all the details about R. We are going to be determining the X component of R and the Y component of R. R sub X, that would be this one, and R sub Y, that's going to be that one. Now, B is the easy vector to work with because B is completely in the X direction, and they did say that B was 0.50 kilometers. They said that this angle here was 60 degrees. We'll put a 0 on there. And they said that A had a magnitude of 0.40 kilometers. Now, in order to add up everything, oh, I forgot to put in B's values. B is going that way, which is the negative direction, by 0.5 kilometers. Okay, 0.50 kilometers. In the Y direction, B is going 0. Now, we need to find the X component of vector A, and we need to find the Y component of vector A. All right. A sub X is going to be the full length of A times either the sine or cosine. Since the X component is opposite our angle, we've got SOHCAHTOA, and opposite side and our hypotenuse is linked together by sine. So it's going to be the magnitude of A times the sine of the angle associated with A. So that is going to be 0.40 kilometers multiplied by the sine of 60 degrees. And so, well, I don't need to put it down there. But as far as my calculator is concerned, I am going to put 60 degrees into the sine function, and then I'm going to multiply that by 0.40. I don't have to type in. So I get 0.346 for the x component of a 0.346, and this is again kilometers, extra significant digits for halfway values, and that is to the left, so it is also negative. In the y direction, the y component of a is going to be a times the cosine of the angle associated with a. Now, I know that if x is sine, then y is going to be cosine. If x was cosine, y is going to be sine. But let's check. The cosine function links the adjacent side, this is adjacent to that angle, and the hypotenuse. So that is the correct one to use. So 0.40 kilometers multiplied by the cosine of 60 degrees. And so 60 degrees going into the cosine function multiplied by 0.4. So we've got 0.2, and that's an exact 0.2. So 0.200 kilometers. Add those up for the resultants, and we get down here negative 0.846 kilometers, and of course over here is simply 0.200 kilometers. All right, now we can figure out what the value is for r now that we have our individual values. The length of r is equal to the square root of the x component of r squared plus the y component of r squared. That is, of course, the Pythagorean theorem, because this red triangle here is what we're dealing with. So that's equal to the square root of negative 0.846 kilometers getting squared, and the negative is inside the square, plus 0.200 kilometers getting squared. Then we add them together and square root. So the full magnitude of r, let's see, 0.846, make sure it's negative, then square it, plus 0.2, I'm not going to bother with the 0.00, but I have to remember to square that. I square rooted it, I don't know why I just did that. All right, let's try this again. 0.846, make it negative, stop hitting this shift button, square it. I'm not even convinced I did it right. 0.846 negative squared, okay, plus 0.2 squared equals, now I'm going to square root that whole mess, and I get 0.8. Now I got to go to the two sig figs that my problem had, 0.87 kilometers. This is the length of my resultant. I also need the angle that it's at, and the angle that's associated with r is comes again from the components, and we have an opposite side and we have an adjacent side. That is the end of SOHCAHTOA. So we are going to undo the tangent function for that ratio of the opposite side, r sub y, over the adjacent side, r sub x. And it turns out that anytime we're measuring our angle from the x-axis, it's going to be y's over x's, because that's rise over run, otherwise known as the slope. Now remember, just as an aside here, the relationship is that tangent of theta is equal to the opposite side over the adjacent side. If I want to get the angle out, I have to take the inverse tangent. I have to undo the tangent function to both sides, and that's why I have the inverse tangent function of the r sub y over the r sub x. All right, final answer here. Inverse tangent r sub y is 0.200 kilometers. R sub x is, and we're just going to use magnitudes, 0.846 kilometers. Kilometers are going to cancel out, so we have a pure number going in, which is what we need. So 0.2 divided by 0.846 equals, this is the number inside, shift tangent, we get an angle of 13.3. If I had 3 sig figs, I got 2, so 13 degrees. Now, remember, this is a compass rose. So that means that when I combine this one and this one, I get that vector r is equal to 0.87 kilometers at 13 degrees. And this is curving up from west. So this is 13 degrees north of west. That is the final answer for the problem. And again, this is probably the most math you are ever going to see in this class. Thank you for watching. I'll go to another video for the next one.